Welcome to our channel ClassFly community. So today we will be doing the revision of the module 5 of basic electrical engineering. So we will be here doing a brief revision of these two facts, and moreover we will be knowing about three-phase synchronous generator in brief as well as three-phase induction motor. Okay, so without wasting more time, let's begin. So it says that the three-phase generator has two main things. One is your stator, another is your rotor. Okay, the stator has three components. One is your stator frame, another is your stator core, and the last is your stator winding. Similarly, rotor has three components, that is salient pole, non-salient pole, and rotor winding. So this is what three-phase synchronous generator construction in a short way is. So the working is a little different. What happens in the working? First we will apply DC, then this magnetic field gets generated, and then the rotor will start moving, which will also make the magnetic field rotate. And then this magnetic field will have a variation which get linked to the coil, and at last inside the coil an EMF will get induced. So this is in brief the working. Now we will know about the synchronous speed. Synchronous speed means the rotating magnetic field, and the synchronous speed equation is N is equal to 120 F by P, where F is your frequency and P is your pole. Now we will know about the frequency of generated voltage. Frequency of generated voltage means that the frequency which got generated here was in the armature winding. Now for the frequency of generated voltage, it depends on the speed of the field as well as the total number of field poles. So its equation is F equal to Pn by 120, where P by 2 is your small p, that is equal to P by 2. That means small p is the pair of field poles, whereas your N by 60 will be equal to your small n, where the small n is the speed of field poles. Now the EMF equation for the three-phase synchronous generator is KD KC 4.44 phi FT. KD is a distribution factor, KC is your coil span factor, or you can say the pitch factor. This pole will only be included when both this factor are stated in the question. Okay, and this phi is your flux, F is the frequency, and T is the turns per phase. And you know that one conductor has two turns. Okay. Now see the concept of winding factor. This winding factor states that it is the ratio of the EMF generated in a short pitch distributed coil to the EMF generated in the concentrated coil. That means short pitch coil by concentrated coil. Okay, it has two main factors. One is your pitch factor. It has two factors, that is, one is a pitch factor, another is a distribution factor. This pitch factor is also known as coil span factor. Okay. Now see, we will move on to the three-phase induction motor. So we know that, and motor, what does an electrical motor do? It is an electromechanical device. That means its work is to convert electrical energy into mechanical energy. Okay, here also there are two parts. One is your stator, another is your rotor. Stator means the stationary part and the rotor means the rotating part. And in this stator there are also three components like the three-phase synchronous generator, stator frame, stator core, and stator winding. Whereas in the rotor there are two types of rotor. One is your squirrel rotor, another is a slip ring rotor. Okay, now see, we will know about the concept slip. Slip is basically means that the difference between the synchronous speed and the rotating speed. Rotating speed means the speed happening in the rotor, and the synchronous speed means the stator is stationary but its magnetic field rotates, and that magnetic field is a synchronous speed. So we can simply say that the rotor speed of an induction machine is different from the speed of the rotating magnetic field. So the slip speed, your slip speed is always equal to your synchronous speed minus your rotor speed, and it will be in the numerator of the slip, and this is your slip, so it will be in the numerator, which will be the slip speed, whereas your denominator will be the synchronous speed. Now you know that in an induction motor there are 3-phase supply, and each of them is lagging by 120 degree or moving with a shift by 120 degree, right? So here what happens, whenever it changes its shift, the phase will change but the magnitude will remain the same. And the last concept is what is that why we needed stator. Stator are needed because at the starting, whenever you want to move a stationary thing, it needs a lot of torque, right? So it will not make the voltage large, but it will make the current large. So due to that, the machine may get overheat or the windings can get destroyed. So that's why we need this stator. So I hope you all understood the revision of the module 5. So today's lecture ends here. Till then, be happy and have a great day. Now is the quote time. The great thing in this world is not so much where you stand as in what direction you are moving. I hope all of you understood the lecture of today, and thank you for
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.